Okay, so now we're going to talk about one of the most basic things that you have to do in programming, which is creating variables. And you'll see that I've already created a class and I've created a main method. And so we're just going to be coding in the middle here. I'm going to scroll all that other code off the screen. I just want you to focus on the basic rules of creating variables. Now, a variable in computer science is a lot like that in math, where it represents some unknown quantity that can change and fluctuate as the program goes on. Now, as you saw in the last video, you know that all data is ultimately represented by ones and zeros, so you need some kind of encoding scheme. Now, as you saw in the last video, integers can easily be expressed using ones and zeros using the binary number system. In actuality, it's a little more complicated than that, but what I want you to focus on is the idea that depending on what kind of data you're trying to store, you're going to need a different encoding system. But imagine if you had to represent the number pi 3.14, a rounded version of pi. You would need a totally different encoding system. Similarly, if you're trying to represent a letter of the alphabet, you'd need a different encoding system. And so what happens is when you create a variable in Java, you need to tell Java what kind of encoding system it should use when interpreting this data. So if I want to create some integer variable, I have to first say int. Then you create some string of characters. So I'm going to call this my integer. And then you can assign it using the equal sign of variables. This sequence of characters is going to be the variable itself. This is the announcement to Java. Please create a new variable that will always be this data type. So my integer, this sequence of characters, can only represent integers. If you want to represent a real number like pi, you use the keyword double, and we'll go ahead and just do 3.14 because that's what I've been saying out loud. The reason they say double is that it uses twice as many bits as an int does. To represent an integer, it only uses 4 bytes, which is 32 bits. But in order to represent a real numbers are so dense. You know, there's so many real numbers, and we'll talk about that in class. You need more bits to represent them accurately. Otherwise, it'll just be too imprecise. So you use twice as many bits to represent a real number as you do an int, and so they call it a double. Another kind of data type you need to know is a Boolean. Booleans are always just true or false, so I'm just actually going to call this, and I'm going to call this false. The word true and the word false are Java keywords. Notice that false turned to blue. And the other primitive that we have to know in this class is a char, which is obviously short for character. You can give it some long name like that, and characters are indicated with single quotes. Variable represents the letter A. So these are the 4 basic primitive data types that we have to know in this class. There are others, but we are not going to use them all year long. These are the only 4 you have to know. Now, these 4 are what we call primitive data types, and the idea is they have their own little encoding schemes, and they are very, very simple. They don't have any complex behavior, so what you see is what you get. Most of the things that we care about in Java, though, are called objects, as I mentioned in previous videos. Strings, which I think you've seen in some of the other videos, are objects. So I can say my string, and the way to create a string is the formal way is to assign it. You use the word new, and then you write the name of the object again, and then you have these parentheses, and sometimes you can put things in parentheses. And in this case with strings, you obviously put a quote, and you can say this is the text for my string. Now this is the really complicated way of creating a string. There's a shortcut, and so I'm going to say string shortcut, and you can just put the quote right there. You saw J frames, I'll make a J frame. Some frame gets new J frame. You saw J label, some label gets new J label. In all 3 of these objects that I've just done, I'm putting a string in the parentheses. That's just a coincidence. What goes in the parentheses of an object at creation time varies from object to object. It just so happens that all 3 of these allow you to put strings in there. We don't know enough for me to give you a better example. But if I hit the compile button, hopefully this will compile. I did something wrong. Oh yes, this does not need a parenthesis there. Oh, that's right, I have to import. You remember you have to go check these things out of the library. I forgot that I need to do that. So import java x.swing. And here's another thing, if you do star, you'll import the whole package, so I can save some typing time. And now I have no syntax errors. Good. So again, what I've done here is on the left-hand side, I am declaring a new variable. and on the right hand side I'm actually creating the object. I can say my integer should become 4, well, let's use a new number, 3 plus 6 plus 6. And then its value should be 9. Should we check to see if it works? How could I check to see if it works? Well, why don't I bring up a silly little window, system.out.println. Again, this is just like a dummy little window that helps me see what values are. My integer. And so what I'm doing is I'm saying, hey, open up a window and print, and notice I'm putting in the name of the variable. So when I close this and I run the main method, I should get a window that pops up, and sure enough, a 9 is printed. Some other cool things you can do is, let's say, integer plus plus. Plus plus is the encoding for incrementing the variable, so this is going to go up by 1, whatever its value is. This only works for numerical variables, though. If I tried to say, here, let's watch this. If I do is finished plus plus, this should be a compiler error. Right, so the compiler's like, what bad operand type Boolean for unary operator plus plus. It basically says, I don't like that. I'll comment it out. Actually, just delete it because I don't want you even remembering that. But if I compile this and print it up, you'll see that it should be a 5. Sure enough, it's a 5. So the idea of these variables is you create them, and then they can represent values and do all kinds of complicated things. Let's say we want to know how many characters there are in this string. What I could say is my integer becomes, again, the equal sign means becomes. It means it is assigned a new value. And then I'll say the myString variable, and then the myString variable has a method, which we saw a little bit of, called length. And the idea is when you call the length method on the myString object, the whole thing becomes the length of the string. So my integer will be assigned the number of letters in the string, which should be 1, 2, 3, 4, 5, 6, 7, 8, 4, 25, 26, 27, 28, 29, 30. Nice even 30. Compile, run. Oh, you know what I did? What did I do? The system.out.println happened before I assigned it to be length, so that's why I got the old value. So I have to go copy that, I'll paste it down there, and compile. There we go, there's my 30. So that's an idea of what variables are, how you create them, and how you use them. I should point out the rules for creating variables. These are soft rules. The compiler doesn't care, but human beings care. A variable should always start with a lowercase letter or an underscore. A variable cannot have any funny characters in it except for an underscore. So you are allowed to have an underscore in there. So you're allowed to have an underscore in it, but you're not allowed to have anything else. If I try to put a, let's say, an and sign in the middle, you can't do that because an and sign is a special value in Java. It means something different, and all the other special characters. So you can only have uppercase letters, lowercase letters, and numbers. You can put numbers in the middle of the variable, but they cannot be at the beginning. And the reason is when the compiler finds a number at the beginning, it thinks it's going to read a number value, not a variable value. So the number can appear anywhere, it can even appear at the end. That's okay, but the first character has to be either a letter or an underscore. This is what we call Camelcase. And this is a naming convention for variables so that you can be very, very specific about what the variable is going to mean. It is considered very, very good programming practice to have very self-descriptive, readable variable names. So a bad variable name would be, like, if you want this to be my character variable, you wouldn't want to call it MCV, which stands for my character variable, because when you go in your program and somebody reads MCV, they're not going to immediately know what that means. So you actually want long, well, not necessarily, you don't want it to get too long, but long enough that the reader can quickly understand it, but not too long that it takes forever to type and your code is running off the page all the way. So you need a delicate balance. But picking a good variable name is critical, and every year students get really lazy with this, and they end up losing points on tests and quizzes because of their own variable name. So I want to really emphasize, pick a good variable name. Pick a name that will describe very precisely what kind of data it will represent. And it makes your code much more readable, it makes it look like English, and it makes it easier for the human brain. The computer's not going to help you with that, right? This is where sometimes your human skills have to come into play. Oh yeah, I forgot to explain Camelcase. The reason they call it Camelcase is because it's like the humps of a camel, right? You got lowercase, lowercase, up. You got a big one. That's like a hump of a camel. Lowercase, lowercase, up. The hump of a camel. But you use capital letters to kind of help the human eye distinguish the end of the last word and the beginning of the new word.